Welcome to Probability and Statistics. This lecture video 4.2, we're going to talk about addition rules for probability. Alright, before we do that, talk about the addition rule, let us take a look at just the rules for the probability. The rules for probability says the probability of any event E, okay? Probability of any event E must be between 0 to 1. Okay, so that means you cannot have a negative probability and your probability cannot be greater than 1. 1 being 100%. Okay, the highest is 100%. So it can be anything in between. Alright. Rule number 2, probability of all the outcomes, okay, must sum up to be equal to 1. So if you have a sample space, event E of 1 all the way to the last event, then if you add out the probability of every single event, it will equal up to 1. This is exactly just like what we talked about in section 2.1, I believe, when we talked about something called the cumulative relative frequency distribution. That big old table that we did in 2.1. Cumulative relative frequency. It always add up to 1 when we add up all the decimals. If an event is impossible, then the probability is 0. If an event is certain, probability is always 1. Now this thing called the unusual event, okay, it's referring to any event that has a low probability of occurring. Alright, and that is to say the probability of an unusual event is always less than 0.05, which is less than 5%. Okay, anything less than 5% is unusually to occur, not likely to occur. Alright, so let's take a look. Determine which one of these number cannot be a probability number. 0, you can be 0. You cannot be 140%. You can be 0.9 because that's between 0 to 1, and 1/3 is 0.3 repeating, so you can be that. So you cannot be over 100% or negative. All right. Another thing I like to talk about now is something called the complement rule. Alright, the complement of an event E would denote as E complement, or E complement with a bar on the top. It's referring to the set of all outcomes in the sample space that are not in event E. Okay, E complement, what is not in E. It's in the sample space, but it's not in E. So my example here says, okay, let's think about a sample space number 1 through 6. If my event E is referring to 2, 4, and 6, then what is not in that event E will be called E complement, which is other number in the sample space 1, 3, and 5. Okay, and we can use what we so-called a Venn diagram to illustrate. This whole thing is your sample space, because this whole thing including 1 through 6. Alright, so if this is an event E, then what is not in the event E is called E complement. Okay, so if I will add the probability of my event E, okay, with its complement, it will always equal up to 1. So that means for me to find the probability of my event E complement, then what I will do is take my 100% 1 minus probability of the event. Alright, or if I want to find event E, if I want to find the probability of something I want, then I will take my 100% 1 minus the probability of what I don't want, which is E complement. Okay, very important concept. Take the total, subtract what you don't want, then you get what you want. Alright, we'll talk more about this as we go along. Alright, find the number of outcome in the complement. Alright, let's find the complement. Out of 340 raspberry plants in the field, 181 are ready for picking. So this problem will make you find how many is not ready for picking. Not ready for picking, that would be the total 340 minus what are ready. So that will give me 159, I believe. Alright, so 159 is not ready, it's the complement. A card is drawn. So this is drawing one card again. From a standard deck of 52 playing cards, what is the probability that the card will be a heart but not a jack? Okay. What is the probability of a heart and not a jack? Alright, as you know, for your standard deck of card, you got suits. You got 4 suits: heart, diamond, club, and spade. Okay, so just being a heart, you have numerical value from 2 to 10, and you got your jack, queen, king, and ace. Alright, so 13 cards under the heart. It does not want to be a jack. Okay, with probability that the card will be a heart. I want to be a heart but not a jack. So there is one card that is actually I don't want, which is jack of hearts. So how many ways I can get a heart but not a jack? Normally you can get 13 hearts, but one of them is heart and a jack of hearts. So that means you only got 12. Okay, 12 ways to choose heart and not a jack. Alright, out of my possible outcome, 52. So 12 out of 52. Convert to a fraction. So this is 0.2308, or you can have a fraction answer. Okay, 3 out of 13. Either way will work. Two, 308. Alright. So complement. The complement will be not a jack of hearts, which is you got 12 ways to select the rest of the hearts. That's what you want. Alright, this example, let's suppose a coin is tossed 9 times this time. What is the probability of getting at least, this is a very important word, at least one of our head? Okay, at least one head. So this problem is to find the probability of at least one head. Okay, so how many ways? Okay, how many ways I can get at least one head out of 9 toss? So this is very interesting problem. Okay, all right, at least one head. So let's think about this. Okay, out of the 9 toss, what can I get? Out of the 9 toss, I can get none of them are heads. I can get just 1 head, 2 heads, or I can get 3 heads, the other 6 are tails, 4 heads, the other 5 are tails, 5 heads, 6 heads, 7 heads, 8 heads, or I can get all 9 of them are heads. Okay, this is what I can have. This is my possible outcome. Okay, my possible scenarios, excuse me. Okay, at least one head means what I want is 1 head and more, all the way up to 9. So this is what I want. I want at least 1. That means 1 all the way up to 9 heads. So this 0 will be the complement. This is what I don't want. So the idea of a problem like this is saying, okay, at least 1 head means I can take my 100% 1 minus the probability of what I don't want. Okay, figure out what I don't want and get what I wanted. So minus the probability of getting a 0 head. Alright, so it turns out I'm gonna show you how to count this later on too. Okay, so it turns out 1 minus, alright, how many ways I can get a 0 head? It's actually only 1 way to get no head, because that 0 head is referring to all of them are tails. All 9 are tails. That can only occur 1 way. Out of, if I flip a coin 9 times, my total possible outcome would be 512. So if I take a 1 minus parenthesis 1 out of 512, convert it to a fraction, that's going to tell me I will get 511. There are 511 ways to get at least 1 head out of my total possible outcome, 512. Okay. So again, I will teach you how to count a little bit more. How do you figure out this 512 and such? So if you type in this as a decimal, you will see this is about 0.9980. Alright, let's try this again. A standard pair of 6-sided dice is rolled. So we're rolling 1 die. Excuse me, we're rolling a standard pair. So we're rolling 2 dice. What is the probability of rolling a sum less than 8? So this example actually reflects to our project number 1. I want a sum that's less than 8. So we can actually count this pretty easy. Okay, we can count this pretty easy. If I roll 2 dice, the minimum sum if I roll 2 dice, the minimum sum is rolling a 1 and a 1. So if I add a 1 and 1, the minimum sum is 2. If I roll, the highest one I can roll from each die is 6. The other one's 6. So if I add up the sum, that would be 12. So my possible sum is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are my possible sum I can get. What is probability of rolling a sum that is less than 8? So what I want is from sum of 2 all the way up to 8, but cannot say 8, it just say less than 8. So that means what? It got to be from 2 all the way up to 7. Okay, this is what I want. Alright, what I don't want is 8 all the way through 12. So we can tackle this from 2 different directions. We can figure out exactly what I want directly, or I can figure out what I don't want directly, then subtract it from 1 using the complement rule. Alright, so if I want to do it directly, okay, sum of 2, you can roll sum of 2 by only rolling 1 and a 1. So let's figure out this directly. To roll a sum of 3, I can roll a 1 on one die, 2 on the other die, or I can roll a sum of 2, the other die says 1. Sum of 4, I can roll a 1 with the 3, or I can do a 3 with the 1, or I can do roll a 2 and a 2. Sum of 5. I can potentially roll 1 with the 4, and then the other die will have a 4 first and a 1 next. Then I can do a 2 with the 3, and then a 3 with the 2. Alright, so there's 4 ways. Sum of 6. Roll a 5 with the 1 with the 5, 5 with the 1, 2 with the 4, 4 with 2, and the last one gotta be 3 and 3. Okay. If you roll a 3 and a 3, or 2 and a 2, these two is not distinguishable, so you only count them as one way. Sum of 7. 1 with the 6, 6 with the 1, 2 with 5, so that means I got 5 and 2, 3 with 4, and last one, 4 with 3. Alright, so these are my possible ways. Alright, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Alright, so that means probability of sum less than 8 will be 21 ways to roll a sum less than 8. Out of my total possible outcome, I'm going to go ahead and tell you what it is. It's 36. Okay, show you how to count later on. So 21 out of 36. Give me about 0.5833 repeating. Convert to a fraction. 7 out of 12. Alright, so if I want to do the complement rule, I will figure out how many ways that I don't want, and then I will subtract it from 100%. Okay. So if the total is 36, how many ways I do not want? If you subtract, that will tell you there are 15 ways I do not want. So as you can see, this problem is actually easier to figure out what I don't want, which is the other 15 versus the 21 ways that I wanted. Okay. Alright. Let's try to take a look at something called the addition rules for probability. Alright. Addition rule for probability says if you got 2 events now, 2 events, okay, 2 different things happening that are disjoint or the word mutually exclusive. Disjoint or mutually exclusive. That means if the 2 events have no common outcomes. So for example, this Venn diagram shows that, alright, I got the card 7s and all the face cards. Well, there's no common outcome between all the face card versus the 7s. I know it's kind of okay. We're just talking about. We're not talking about suits. We're talking about all the face card. Jack, Queen, King. Okay, versus their 7s. There's no common outcome. So if you have no common outcome, alright, if your 2 events are mutually exclusive, then the probability that first event E or second event F occur is going to be probability of the first event or the second event will be probability of the first event E plus probability of the second event. So in probability, the word or means we will add the probability. Okay, mutually exclusive. For both events to occur, E or F to occur, we will actually add the probability of the two events if they are mutually exclusive. Now, if the two events are not disjoint, not mutually exclusive, so that means they have a what? Common outcome. We will subtract the overlapping part. So what I mean by that is, this picture shows choosing either a heart or a queen. So you got your 13 hearts and you got your 4 queens, but there's one card, okay, queen of heart, that's in both of these, okay, but you can only count this card one time. You cannot count this card twice. So we will subtract the one extra time we count. Because if you look at it, this is 13 ways to choose a heart. The other one is 4 ways to choose a queen. So if you add them up, that's 17, but you actually count the same heart twice. So you gotta subtract that one time you count it twice. So that means there are 16 ways to choose a heart or a queen. Okay, you win if you select a heart or a queen. So let's see if I can get cards. I don't know. Standard deck card. I just want to see if I can pull out some cards for you. No, don't have it. I got dice. Alright, so generally speaking, additional rule says for probability of the first event or the second event to occur, we will take the probability of first event plus probability of second event and minus probability of the first and the second event that occurred. So this is the overlapping part we will subtract. Okay. So for example, okay, when we do, what you're looking for here is the word or, and you got to think about, are my events mutually exclusive or not? So if we do A, compute the probability running selecting a heart or a club from a deck. Alright, probability of selecting a heart or a club. I'm only choosing one card, but I got 2 different events going on. Alright, so are these 2 events mutually exclusive? The answer would be yes, because both of these are suits. There is no one card that has both heart and a club on it. Okay, so that's why this is mutually exclusive. So all we're gonna do is add up their probability. Okay, so that means how many ways I can choose a heart. Okay, there are 13 hearts out of 52 possible outcomes. And how many clubs? There are 13 ways to choose a club out of 52 possible outcomes. So as you can see, okay, if you know your cards, you know this answer eventually will be a half, because these 2 suits, okay, covers half of the deck, because the deck only has 4 suits. Okay, so 13 plus 13 will give me 26 out of 52, so which is result into a half. Okay, alright, so let me just write this out. I don't think this is that bad. It'll be a half. Compute probability of running selecting a heart or a club or a diamond. So this time I got 3 events: club, heart, diamond. So none of them, well, all 3 of them are mutually exclusive. And heart or club or diamond. So this time I'm just adding another suit. So my final answer got to be 3/4, because now these 3 suits should already cover 3/4 of the deck. Okay, and you can do the same thing as I did up here. 13 out of 52 plus 13 out of 52 plus another 13 out of 52. It will result to be a 3/4. Alright, part C. Here we go. Compute the probability of selecting an ace or heart. Okay, select an ace or a heart. So this time, okay, we're gonna think, okay, this is gonna be the probability of getting an ace plus probability of getting a heart. But there is one card that is both of these, which is ace of hearts. So if I will count this correctly, ace and the heart, if I count this thing correctly, I believe that probability of getting the ace there should be 4 ways to choose an ace. Alright, there are 4 ways to choose an ace out of 52 possible outcomes. Plus probability of choosing a heart got to be 13 out of 52. There are 13 ways to choose a heart out of 52 possible outcomes. So right now I got 17, just like my example up here. Now I got 17, but the ace of heart is actually counted twice. So I gotta subtract that 1 extra time I counted, which that at 1 extra time got to be 1 extra card out of 52 possible outcomes. So my answer is actually gonna be 16 out of 52. So 16 out of 52 is about 30.8%. Convert to a fraction, it's actually 4 out of 13. Okay, so the 4 out of 13 is it's kind of hard to comprehend. So what's easy to comprehend is there are 16 ways, okay, to choose a heart or an ace out of 52 possible outcomes. Okay, that part is the part we're trying to comprehend. The 4 out of 13 is my simplified answer. Alright, let's take a look at some other examples here. Let's say a pizza delivery company classifies its customer by gender and location of residence. The research department has gathered data from a random sample of 1450 customers. The data is summarized in the table below. So what do I have here? I got different residents, different place, location of residence, and we got gender. The question asks, what is the probability that a customer, so I'm selecting one customer right now, is a male? Alright, so here are my events. My event male. Oh, excuse me, sorry. Male and live in the dorm, that's one event. Or, so my second event, or is a female live with her parents. Okay, selecting one person that can either be a male living a dorm or it can be a female living with its parents. So let's see what I got here. Alright, do I have an overlapping outcome? Is it mutually exclusive? Can you be a male living a dorm and also be a female living with the parents? The answer is no. You cannot be. Okay, you cannot be living a dorm. Okay, well, to be honest, you can't really be male and female at the same time. You can be male changing to female or female changing to male. But so these are two separate events. Okay, you cannot live in two places at one time. Okay. In other words, you cannot ride two horses with one butt, kind of like. All right, so let's find where we are on the table. Male living in the dorm. All right, that's 278 customers. Female living with the parents. That'll be right here. So there's no common outcome. Okay, so mutually exclusive. So all we're gonna do, okay, is take 278. Okay, there are 270 ways to choose that one person out of 1450. Plus, the word or means plus. Since it's mutually exclusive, we're just going to add. We don't have to do any subtracting. 234 out of 1450. Alright, so if I add them up, there are 512 ways I can choose that one customer out of 1450. Alright, let's put in the calculator. 512 out of 1450. So that's about 0.3531. About 35.31%. There you go. Okay, that's your answer. Alright, let's do the same type of problem. This time we're going to have 1945 customer. Okay, this is about newsletter. What is a probability that a customer is not female? Excuse me, not male. Or does not live in an apartment? Ooh, this is trickier. Not male. Not male means females. Excuse me. Not male is referring to these. Does not live in an apartment. Does not live in an apartment. Well, this is the tricky part. Does not live in an apartment is referring to these females, 78 down. And it's also referring to not living in the apartment. Not living in the apartment. So it's also including these guys right here. Not living in the apartment. See that thing turn green right there? That's all. The green one is the overlap with the yellow. Okay, the first event say not female, so that's all. Not male, so that's all the female here. But the second event is only referring to not living in an apartment. Not living in an apartment is what? Is dorm, parents, sorority, house, or others. So I have to highlight not in an apartment. I have to highlight all the one that's not living in an apartment. So I actually count. So I will end up counting these guys 2 times if I'm going to count it correctly. So since I know these 4 numbers will be counted twice, I'm only going to end up counting them 1 time. All right. So if I add up all the one I highlighted, okay, so I have an overlapping outcome right here. So I kind of knew I have a common outcome right here. So I kind of knew that ahead of time. So when I add up my first event and the second event, I'm not going to count these 4 numbers twice. Just only going to do it 1 time. So the 100 plus 78 plus 277 plus 214 plus 237 plus the 293, 256, 215, and the 148. So that will be 1818. So that will be 1818 out of the 1495. And I can type it in, convert it into a fraction, or write 4 decimal places. it's a little bit tricky. Not male, so that's all the female. Does not live in dorm, so that means all the people does not live in dorm. You're gonna count those. It's just the one I highlighted twice turned into green. I don't want to count those 2 times. I can only count them 1 time. That's the common outcome. Alright, let's try another one. We'll come back to this one. Let's do one more that table thing. Credit card company this time. 1775 customers. What is the probability that a customer is female? So this is only one event, female. So that means I'm only gonna count the female. I only have one event here. Alright, so let's add them up. So it'll be 714. Did I type in right? 158, excuse me. Type in the first number wrong. 722. So now 722 is female out of 1775. Total possible outcome. So when I choose a customer that is female, I have 722 ways out of possible 1775. And I can type it in, round to 4 decimal place, 0.4068. Alright, let's do this one right here. So a box contains 15 large marble, 11 small ones. Each marble is either green or white. Whoa. 9 of the large marble are green and 3 of the small marble are white. Oh my goodness. Okay. Alrighty. So this is too complicated right here already. Alright, so the trick to do this problem is draw a table. Okay, draw a table just like all the other ones. So let's see what I got here. Okay, I got box contain 15 large, 11 small. So I got large and small. Large and small. So let's say this is large and this is small. Okay. Well, that's a good start. And then it says something about each marble is either green or white. So I got green and the white ones. Okay. Alright. 9 of the large marble are green. So 9 large marble are green. So that's 9 right there. 3 of the small one are white. So small and white, that's 3 of them. Right there. If a marble is randomly selected from the box, what is the probability? Okay, what's the probability that is small or it's going to be white? So that's 2 events right there. It does not say small and white. It's saying small or white. Alright, so I gotta figure out all the small ones and I gotta figure out all the white ones. And I'm gonna have an overlapping outcome or common outcome here in a minute. So check this out. Alright, right now, the problem in the beginning says about something about 15 large marbles. So large, none of them are green. Total is 15. The total is 15 large, 11 small. Okay. So that means 15 minus 9 will tell me so many white. 11 total small minus 3 will tell me there are 8 green ones, small. Alright. 15 minus 9, 6 are white ones and large. Okay. Now, let's have a total down here. Alright. What's the total amount? What's the total amount for being green? Well, 17 green. 9 total are white. Alright, so once you figure out these numbers, probability of small or white. Okay, so that would be, ideally that would be probability of small if you follow the formula, plus probability of being white minus the probability of being small and white. Okay, that's what the formula will say. Alright, so let me highlight. Let me do some highlighting here. Small. Okay, this is small, which is 11. White, or it can be white. This is white. So that this 3 is in green, so this 3 will end up being counted twice. So if I say small, which is 11, okay, out of, how many total possible outcome do I have here? What's my total possible outcome? So if you actually add up, okay, large and small and green and white, this number right here will be the same number, 26. If you add up this way or this way on the outside, it'll tell you the total number is 26. 26 possible outcome. So inside this 11, you got 3 that are white as well. So if you do the white, I'll follow the formula. Go ahead and write this down. The white one is 9, and inside that 9, 3 of them are also small. So if I add up the 2 together, I already count this 3 twice. So that's why I have to subtract 3 of them that are small and white that I end up counting it twice earlier. Okay, on the 26. There you go. So 20 minus 3. 17 out of 26. That's my answer. Okay, so you can do it by the formula, or you can just look at it. Alright, cannot count this twice, only one time. So that's 9 plus 8, 17 out of 26. Okay, you can do it that way. I just want to show you the formula one more time. So, alright, addition rule. Okay, the word or means addition. When you do or, you got to think about whether my 2 event has a common outcome or not. Are they disjoint or not disjoint? And we also introduced the complement rule as well. Okay, with that one example has the word at least. We'll probably run into that a little bit later on. So very, very powerful, the complement rule. Let me see. Okay, to figure out what you want, which is a lot of ways. Okay, rather than figure out what you want directly, we can figure out what we don't want, and then take 100% minus what I don't want, and that will give me what I wanted. Alright, very powerful technique called the complement rule. Alright, that will conclude this lecture video.